Hi folks, Joseph Kursky here. If you're teaching geography, human geography, physical geography, engineering, infrastructure, geodesign, GIS, access, equity, any of those topics, these 3D scenes from one of my favorite people in all of GIS, Raluca Nicola, might be a great teaching tool. I've got the URL in here for you. San Francisco walking time to public transport. The dark is less than a minute. The lighter tones are more than 19 minutes. San Francisco. Fascinating to be able to explore the patterns, the relationships, and also talk to students about how these web mapping applications are created. If your students get a little bit of savviness in Jupyter Notebooks, the ArcGIS developer platform, get some Python skills, they too can create web maps and scenes like this. But this is just fascinating. Even in this medical complex or this office complex, you can see the different tones indicating different minutes walking time to public transport here in San Francisco. You can also, of course, discuss the physical geography of San Francisco with these 3D Microsoft buildings that are overlaid on here. But I also have my students in an activity where I use this map. I have them look at wheelmap.org. It's a public crowdsourced map based on OpenStreetMap of wheelchair access. So if we considered mobility challenged people, how would that change the number of minutes to public transport? And where are the public transport lines? That would be another good thing to actually have on here as well. But how would that accessibility change? A lot of people I know on wheelchairs, they're faster than people walking. So a discussion would be good to have. Does it change? It increase? Does it change in the decrease side of things? Time to public transport. And how do we decide where public transportation lines should be located in the city? That's another thing to talk about with your planning students. Who decides? Does it get community input? What about bus versus light rail versus connections to ride shares, connections to airports, things like that? Who decides where these lines get built and where they expand in the future, and who funds these projects? This is all quite fascinating, and again, GIS is the perfect tool to spark discussion on these important topics. So take a look and teach with this. This could be a half-hour lesson. This could be a multi-day lesson. You could look at different cities as well with 3D scenes, and with the ArcGIS platform, look at transportation lines, median household income, median home value relationship to the transportation lines. What about access and accessibility, like I said, with wheelmap.org, and also looking at median age and where people work, where people recreate in a city, and does that have any bearing on where these lines are located? Fascinating to be able to do this, and I invite you to take a look at not just this tool, but use GIS in instruction. That's my main focus in the work that I do. My colleagues and I, for example, just wrote a book on teaching mathematics using interactive mapping. So that's all about spatial technologies such as GIS to teach core math concepts, set theory, expression building, geometry, trigonometry, mathematics, and much more. Thanks for being with me.